Right, so my name is Omar Santos. I'm actually a principal engineer or a monkey in the product security incident response team at Cisco. Been at Cisco for 19 years, close to 19 years next month, and been in the security industry for a little while. Before that, I used to work for DoD. But what I do at Cisco is basically I investigate all the bad news whenever it comes to security vulnerabilities in Cisco products, services, or things that affect the industry, so even industry peers. So what I would like to do today is give you from a high level, because we only have 50 minutes today, somewhat of a lessons learned on things that actually are, one, relevant to all of us, based out of things that we have investigated and disclosed out there. Second, how this vulnerability management as a whole is actually changing dramatically in front of us, and how actually the industry is not keeping up, to be honest, right? So a couple of years ago, you woke up in the morning and you get a logo, right, of some vulnerability that you actually have to either get familiar with, get not only from a technical perspective, familiarize yourself of some vulnerability that may be in the news at the same time that vendors are trying to actually even provide a patch or even understand it, but also to have actually an overview of have an overview of actually what is the impact in your organization, what are the mitigations, what are the things in place. So nowadays, not only you have that, because you still have logos and websites that disclose the vulnerabilities to everybody, but you also have a little bit different ways that vulnerabilities are being, quote unquote, disclosed or dumped out there, right? One thing that I want to do is a big disclaimer. I'm actually going to go over how we reacted to some of these, especially in the incident response from a product security perspective. I am not going to talk about any attribution, of course, any customer information. I will give you some high-level technical overviews of some of these things and related to the investigations actually we did. If you do have technical questions, I'm more than happy to actually do that. If you have any questions related to non-technical perspective, attribution or anything, I will not comment on that. So that's out of the way. So again, you wake up in the morning, you actually have either a vulnerability that you actually have to patch as a vendor, and then for you to patch as a consumer. And then you have also dumps, not only that provides the details of the vulnerabilities, but actually readily available exploits that the bad guys actually can take advantage of, within seconds, right? That it doesn't take a rocket science or a scientist to actually do harm. And so I'll go over that. So once you start the investigation, all this is actually on top of you, and then probably something like that happened. And so what I'm going to do is I'm going to go over a series of case studies, in all seriousness, but I'm going to relate it to the number of drinks that probably we took after investigating some of these issues, right? So the first case study, and you will see, this probably increasing with the time, it's actually about something that a lot of people here, are familiar with. So how many of you are not familiar with what shadow brokers is? Okay. How many you're not familiar? Okay. So very, very quick. Basically, shadow brokers is an allegedly group, nobody knows, maybe an individual, maybe a group, that they have been disclosing, and whenever I say disclosing, it's basically dumping a set of exploits of an alleged group called Equation Group. And basically, those dumps are real, right? They do have, they provide exploits, and not only exploits, but really detailed instructions on how to execute those exploits against. And again, I'm from Cisco, so I can point fingers to Cisco. So I'm only gonna do that. But attack Cisco devices, attack operating systems, different type of applications. And if you're familiar with WannaCry, one of those dumps included an exploit called EternalBlue that was actually used by bad guys actually to basically create WannaCry, right, as a ransomware. And I'll touch a little bit on WannaCry, but again, I'm only going to be pointing fingers to Cisco, so all the case studies in here actually are related to Cisco vulnerabilities. But one of the things that I want to highlight is, yes, we actually have all this information public. I publish a blog, we have advisories, and event response pages, and we have a lot of collateral on how the technical implications of these issues. I guess fortunately or unfortunately for us, we were one of the first vendors that kind of confirmed that, yes, these are actually exploits that affect our products. And the challenge in that aspect is that you don't know, you have a piece of information that you actually have to investigate. You have to not only investigate the devices that now you sell, but some of these actually affect devices that you don't even sell anymore. What it actually is even worse is that for some of the products that this affect, specifically the Cisco PICs, Cisco didn't even have the people anymore on staff that can even answer these questions, right? So, and at the same time, this is public while you're actually trying to not even have this blog published, right? This is public in the news on CNN and everything. All your customers are actually, and I'm not talking about hundreds of emails, I'm talking about thousands of emails coming in for you to actually just give them some information of things that you actually just have no idea. And then the guy that actually can provide you some information about that doesn't exist anymore. And literally, in some cases, actually, they even have perished. I'm not making this up. The other thing is that some of these, now you're trying to balance, we're not going to have fixes for those legacy, they're end of life. Now, not only customers, but also the media is asking, okay, so there's huge impact. Of course, everybody's familiar with Shodan, all these devices actually exposed there, which still exposed. And they're coming to you and they want an answer, right? So how do you juggle into that? It is not easy, right? But one of the things that at least that we take pride is that we're transparent. So at the end of the day, at least for my organization, we don't sell products. We line stop products for a living. And what we want is actually to patch a vulnerability and make sure that everybody, is safe, right? It's basically the mission of my team in PSIRT is basically to protect the customer and protect Cisco in that order. But anyways, so once you get all this dump, in the case of shadow brokers, now you have to investigate. So what are you going to investigate, right? And regardless of what the media and PR and legal you're actually working with, you actually have to understand the technical implications of the issue to communicate it correctly. Not only that, is that this may not be the last dump, which was not the last dump. So now, what do you juggle, into, is there more? Do I have to actually hire people or get other people within the organization to look for more? So at any rate, the updates, and you will see this, we first started with a blog post and an advisory of the actual issues and patches that we actually provided. But as you see, everything started in 2016. And then again, another dump comes in, and everybody actually, believe me, they already knew and had this thing bookmarked, and even media articles actually had them. So we didn't want to create another document, so we were just updating in there, right? Oh, yeah, there's nothing that affects Cisco in here, and then point people to collateral. The challenge in that aspect is that now we're dealing with a non-traditional disclosure mechanism, right? That you have blog posts, people are actually reading the news, and they probably have more technical information in some cases in those news articles or some other people's blog that what even, we actually had in the beginning, right? So it's extremely tricky on that perspective. And what they put the cherry on the top is that this exploit, whoever actually put the names in there, they're amazing. So this is the first time that I talk to the media and I have to explain what is extra bacon or epic banana. I mean, it's just, I will never even, dream of something like that before, but that's what it is, right? So at any rate, so we had tons of collateral, we make this available to you, and of course you're most of you are familiar with all these already. But again, how can you as an organization or probably as the community can keep up with something like that and make sure that we have fixes in place, that people are deploying the fixes and they understand the technical implications of it, or the actual mitigations in place. In a lot of cases, actually, you cannot even get the fix, right? So you have to mitigate across the network. Now, for those of you that are not familiar with the Epic Banana Extra Bacon, let me take a second. This is probably at least from a high-level technical implication of this. So Epic Banana, actually, let me start with Extra Bacon. Extra Bacon is an SNMP remote code execution vulnerability against Cisco ASAs and Cisco legacy PICs, right, firewalls. And what it is actually literally with an SNMP packet, a crafted SNMP packet, you can actually do a buffer, invoke or induce a buffer overflow to actually happen, and basically you have the remote code execution capability. And especially in the PICs, which actually, was sold over 10 years ago, you didn't have things like remote runtime defenses, secure boot, image signing, and all of that didn't even exist at the time, right? So for those devices are definitely more critical, but it is real. And in the blog that I highlighted there, I go through the technical details, the implications of it. And whenever we first published that blog, it just went all over the place. One, from a political perspective. Second, from a technical incorrectness perspective. Third, also, I don't know how, but they were also inferring that these vulnerabilities will impact other vendors, right? But specifically, all of these exploits, specifically in the shadow brokers dump, are for a specific vendor, right? But anyways, so you're dealing with this with the media, you're dealing at the same time with the technical aspects, and it's basically all hands in deck. And from that perspective, the challenge is that even if you have a lot of process, and we are very, very process-oriented, you can pretty much take that process and go like this, throw it to the trash can. And why? Because I will not say that completely discarded, right? I mean, you still have internal communications. Basically, at Cisco, what we do is for anything that we have the luxury, of disclosing internally, we have created a hot page prior to publication. So the support teams are, ready to answer questions from customers. The PR is also, have some customer facing blurb. And then also, to actually explain the technical details. So if you're an engineer, of course, you actually have some instructions on how to potentially mitigate this issue, or perhaps, IPS signatures that you can deploy to do this, snort, for example. And then for the external communications, of course, we have a really, really, really detailed process on how we do advisories and who reviews us and everything. In this case, literally, you review and publishing the advisory probably within a couple of hours after something being dumped, right? And this is not new, not only for things like the shadow brokers or any of the recent ones. We saw that in Heartbleed, right? Heartbleed was actually in the news and was in the register even before any vendor, except the one that found it, had an advisory out there or patches. OpenSSL, of course, is actually used pretty large. But whenever it's specific to a company, it's also extremely hard to actually follow these processes that you have in place and accelerate them into the fact that that you have to have not only the technical folks, not only the people doing the patches, not only the guys actually literally hitting the button to publish this thing, but the people that are going to support you after that, train, which you cannot do that in a day, right? But you have to, right? You have to figure out how to do that. Now, so that's kind of behind us. Most definitely it's not going to be the only one of this nature. But that was kind of a wake-up call recently, even very different than a Heartbleed or Shell Shock or Puro, of the world. Because now you actually have the exploit readily accessible by a bad guy, and you're actually seeing exploitation with him I will not say minutes because we were not even monitoring at that time, but I will say within the same day, you will see exploits actually being used by bad guys. So I have a separate case study that even I'm gonna go over pretty high level, knowing the technical aspects of it, but even if you had those marvelous processes that I mentioned before, all that internal communication and teams, I'm kind of spoiled because we have teams that can do reverse engineering, some of these, exploits and vulnerabilities, and teams that can do the IPS signatures, teams that actually will do, for one of the vulnerabilities, actually, I forgot to mention Epic Banana. That is, again, a pretty severe vulnerability that you can actually extract the VPN keys of all PIX firewalls, and there are about 300,000 of them still active. I was checking it yesterday at B-Sides with a colleague of mine. That is exposed to the internet, that they're actually, listening to port 500. I'm not saying that you can get all the VPN keys, but they're listening to VPN port 500, and it's real. Then we took a look at that. We modified the exploit, and that's where I guess being spoiled is. We had some really good technical guys that took the same exploit from there, created their own, and they made it work against iOS and iOS XE. And then after that, we actually had to publish, and it's part of the collateral that I share there. We had to publish an advisory, and even though we internally found these issues and we internally tweak that to actually make it work, we're fairly transparent. Actually, I average right now at Cisco 2.5 vulnerabilities that we disclose per working day. Yeah, that's a lot, right? And I guess we take pride because and for me it's not that much pride because we're not finding 100% of them, but the majority of them, over 70% of them, are internally found, right, nowadays. But we disclose them the same way that if there's a shadow broker's dump or a researcher is actually doing this as a crack attack. But at any rate, it's a lot, and not only is a lot, I'm anticipating that it's actually going to continue to increase. I wish I can give you 20%, 10%, 50%, but it's going to be in the magnitude, probably doubling in the next 2 to 3 years, and you will see that. Anyways, going back to this second case study, this is a vulnerability, and I don't know if Amanda is here. Nope. So she's a colleague of mine that pretty much took one for the team there. And we got a report from Google Project Zero, which actually we work closely with them, Tavis, Osmandi, specifically, that basically found a remote code execution in a plugin of WebEx that affected, just in the Chrome store, about 2 million users, right? And then, of course, Mozilla, if you account that, is probably about 7 million or so. And basically, just like any other vulnerability, we have that process that we investigate. We were working with them. In this case, it's way different than if you actually patch a vulnerability, let's say, in a router switch or a firewall. Why? Because now we're talking about a cloud service that your software is not in your premise. The software is actually in the Google store or in the Mozilla store because it's a plugin. And now you actually have to figure out how to not only coordinate with them and internally, but the lesson learning here is that whenever you have a global team, and especially through acquisitions, it's pretty hard to actually coordinate a lot of these communications, right? So even if you have these processes, it's super hard. So what do, right? Well, you get a team of people. Typically, what we do in our case is typically 2 people. For this, we had a few more. So Amanda is actually working with Tavis as a researcher, again, Google. There's a different entity at Google that is the store, folks. And your business unit is actually used to, hey, I make a fix, and definitely for things like this, it's almost like it's continuous delivery. They just go ahead and submit stuff to a Google store. What is comical in here is that the WebEx team, in our case, again, I'm pointing fingers to Cisco, the WebEx team in this case actually pushed the fix, right? But we were not notified. Even the researcher was not notified. So the store guys, told Tavis Osmandi, hey, the fix is there. And of course, the fix was not for that vulnerability. So, of course, what do you have in the morning? Boom. You wake up, and there's that's one of them, but there's tons and tons and tons of others. And you wake up, what the hell just happened here? At 11 o'clock in the evening, we had a plan, and all of a sudden there's a register article about it, right? So again, whenever it comes to incident response, coordination, and I'm not talking about internal coordination, even external coordination is crucial, right? Because this thing, first, it was not the true fix for that issue. So not only that article was there, if not, there were following articles saying, hey, the issue was incorrectly fixed by Cisco. And it was incorrectly fixed by Cisco, but that was not the actual final fix. So we had to scramble, So it's a big eye-opening that now how we develop code and we use code and we publish and we disclose is changing dramatically, and it's not the same, hey, what is the latest vulnerability of Cisco that I'm going to go to cisco.com and download it, if not that it may be, and as a matter of fact, Mozilla just blocked, whenever this was out, the plugin for Cisco. So there were, we're talking about hours, not days. We're a lot of people, in the hundreds of them calling Cisco, say, hey, I cannot make a WebEx. I'm afraid that I'm not going to be able to make a WebEx call, right? So you're dealing with all this at the same time. So that's whenever your level. I just couldn't take it anymore, right? So from that on is just all bets are off. It can be whiskey, it can be wine, it can be whatever, but and then you have something like this. How many of you are familiar with what crack is? Actually, let me make the. How many of you are not familiar with crack? Okay, so I got a couple. Very short. If you don't know, there's a website for it, of course, and I publish a blog for it. But crack stands for key. It doesn't start for what you think, but it's key reinstallation attacks, and it was actually discovered by a researcher in Belgium. His name is Matthew, and so I'll refer to him as Matthew from now on in here, so you know that it's the researcher. And basically, again, if you're living, I'm not saying that you're living under a rock, but if you're not, the paper is actually, available there. It's not a vulnerability. What he actually found is a series of vulnerabilities in WPA. It's a protocol level vulnerability, right? Even though some people actually say implementation, but it actually affects every single vendor that produces either a Wi-Fi, a wireless device, like a router, an AP repeater, or a client. That means a supplicant, right? So what is the impact? Well, yes, it's very severe. Of course, you have to be in proximity to the device to launch the attack. And basically, the paper actually is fairly detailed. I am surprised that there's actually not that more readily available tools, but there are. The researcher also made some tools. If you just look at the diffs for something like host IPD or WPA supplicant, it doesn't take a rocket scientist to actually probably figure out and create your own exploit. And basically what it is actually attacking or leveraging the four-way handshake of WPA in a series of ways to get either the group key or the peer-to-peer key, and there's different. That's the reason that the key reinstallation, and it's mostly of forcing reinstallations of those keys. And if you're successful, I guess as a worst case, you can eventually, as a secondary, attack, decrypt traffic that you have actually captured. So that's like the worst, right? Can lead to remote to a denial of service condition as well. So each vulnerability, of course, has different implications, but at the end of the day, that's what it is. And there are 10 vulnerabilities. But let me actually go over somewhat of a time frame. Oh, man, my animation didn't work. I guess. So Matthew contacted us around, I don't know if Dario is here. It was about July time frame. The exact date, I don't know, but it's late July. And basically, the researcher in this case is not the typical security researcher that is familiar with a lot of the disclosure policies and everything. Basically, he's an academic, super smart researcher that found this issue. And of course, Cisco, he probably saw that, hey, there's a Cisco logo there. He actually tested, of course, he knows what WPA is. So he contacted us and also contacted another gentleman. His name is Juni. He's the main guy behind the WPA supplicant Opensource and the host IPD, right? And basically, he's saying, hey, this is actually not a Cisco-only issue, but, I guess we're contacting you. And I went like, well, we went, have you contacted PSIRT, Coordination Center? And basically his response was, he's not a security guy. What is PSIRT, right? And that's whenever we realized, holy crap, this is gonna go sideways, it's gonna be leaked. And basically the reason that I have that in the middle is because it's just going like that, right? We told him, hey, will you allow us not only to engage PSIRT with you, which absolutely he did, and then I provided the technical information so you can start contacting all the vendors. But also, we are members of an organization called ICASI. It's a non-profit organization that Microsoft, Cisco, Intel, Juniper, VMware, Amazon, we're all under NDAs, and we can discuss these type of vulnerabilities. And believe me, whenever it comes, that's what is a little bit what I do at Cisco for the typical engagement that you have with a Cisco employee. But what I do for a living is actually I line stop products for a living, right? So I don't care if for fixing a vulnerability I have to actually work more with my competitor than I do with my own engineers. In some of these things, I was on the phone more with Juniper and my competitors than even my own engineers at Cisco. And of course under NDA. In a lot of cases actually, because the Wi-Fi Alliance actually was engaged as well later. So of course, we're Cisco, so we have representatives of this type of forums in a lot of places that say, well, there's a rumor of a vulnerability actually going on. I'm like, what? Where you hit that rumor? And that's what I say. It was actually a miracle that this thing was not actually leaked before. So anyways, we advised Matthew to actually contact PSIRT. We engaged ICASI. In ICASI, we even saw, okay, this is even bigger than the Microsoft and everything. We're talking about, your mobile device. We're talking about IoT devices that will never, ever, ever get that patch. We're talking about third-party software that we need in order to fix the Cisco gear, especially, like low-end IP phones for small business that I cannot even tell the guys that create the product, because then I'm going to be telling them that company X, and especially also in the open source, is actually impacted, and I cannot do that, right? So all these type of things are not the typical incident response that you do, again, from an epic banana that you have in front of you being dumped, and you can actually control that, even if it's in the news, right? Now you actually have to deal with also providing technical explanations of what the vulnerability is about to probably, and I'm not saying that some of these open source is actually maintained by just 2 people, and actually those probably 2 people are way smarter than us, but in some cases actually to smaller companies that they don't even have the staff to, in order for them to actually even understand what the technical implications are, and basically you have to actually collaborate with them to provide fixes, right? And to provide fixes, whenever I say, I'm not saying that only a fix to a Cisco device, but fix to everything. If you patch, and I'm not going to go into a lot of the technical details, but basically one of the vulnerabilities attacks fast BSS, and it's basically a feature of 82.11r that provides roaming capabilities. And even if you patch, that's mostly the vulnerability that affects infrastructure devices. So even if you patch that access point in there, and you don't patch the client, you still can be successful to carry that vulnerability. And again, that's only 1 out of the 10 of them. And I'll give you somewhat of a story of why 10. We start with 3. Whenever Matthew had the original paper and also a tool to actually test, in the beginning we were referring to this as 3 vulnerabilities, right? Now, whenever, even though you did the research, and he is by far one of the smartest wireless guys that I have ever dealt with, definitely smarter than me, he didn't realize the impact and the actually scope of what he actually found, right, in the beginning. As a matter of fact, he was not even, that we now have a logo, right, and everything. He didn't have that logo like 3 days before he published. He didn't register crack attacks until 3 days that he published. He didn't even know what PSIRT was in the beginning. But then whenever you have more people in the middle looking at things, then you realize, oh my God, yeah, you're referring to this issue in section 2.6 of your paper, but you only have 3 CVEs, but this is actually a different vulnerability. And you explain to the researcher that found the issue, and he's like, wow, that is absolutely right. And then another CVE. And then you get other smarter people that actually are implementing the fix, and they say, well, there's a different behavior for message 3 in the handshake that can lead to this and that and the other, and those the last 3 CVEs that we have there, even though the research was actually done and was really scoped by the experts. Whenever you have more people actually looking into this, and hopefully we're done with that, you actually, of course, you're gonna find, right? So now, how do you communicate that to 3,200 vendors that are part of the Wi-Fi? Actually, it's more than 3,500. Sorry, that are part of the Wi-Fi Alliance. You can't, right? So you have to leverage PSIRT and everything. Not only that, even PSIRT doesn't have, or Wi-Fi Alliance. Those are the ones that has a Wi-Fi logo, right? Only, but there's many other devices, especially in IoT, that they don't have that logo, right? They don't even can afford to actually go through that certification process that they probably, now they're notified because it's in the news, but they would have never been notified ever, right? And in some cases, actually, they come to you and says, sorry, but, we don't have the staff. I got this from the ones that are actually using open source, like the WPA supplicant and everything. Of course, it's just going to patch. But in some cases, actually, most of them straight, they will tell you, we will not patch this, right? So again, it's a huge dependency on why the line's in the middle. So whenever, and actually kudos to those, is open and public now. There's a company called Cypress that they actually produce also software and hardware products, especially in the component level, that even, I didn't even know, but also Cisco actually uses them. So now I am with them on the phone, and as a matter of fact, those last 3 vulnerabilities that I mentioned was one of the guys from Cypress that actually found it while he was implementing the fix. And through iCASI, again, with a whole bunch of NDAs, with a platform that actually, only you monitor and you only give access to specific individuals from each company. So even with that, I cannot make available the diff of those fixes, because if I give, not me, but I actually was coordinating the whole thing with iCASI, but if I provide that or leverage that to the community, basically I'm disclosing the vulnerability in Cypress product, so I can't. So even for Cisco, in some cases, that they were saying, oh, is Cypress impacted? I had to say, I do not know, even if I knew from, I guess, July or so. And that's the trick of the dependencies that now we have every day. And what actually it leads to more drinking. And what it used to be in the past, right? How we created code before, especially for things like were ancient, like iOS, and monolithic like iOS, is like some guy probably with a whole bunch of glasses, right? Oops, sorry. Whole bunch of glasses like that. Say, oh, let's create this new feature for a router, and whether they were drinking or not, actually probably they were, but you got it, and you sweat your behind, and you get a new feature, right? So that's how we used to do code. Nowadays, this is how you create an application, and my apologies for the ones in the back, and I see that it's kind of bad. But right now you have this much code that is imports from other things. It can be open source tools. It can be a tool that your neighbor actually created, or a code that your neighbor created, or whatever. And then you have some function that may also have a vulnerability for something super critical like crypto. And again, this is fictitious. That's why I said Omar's crappy app in there. But you import all this. It can be OpenSSL, it can be Django, it can be NTP Leap, it can be whatever, right? Two guys, that they decided to actually have a repository in GitHub, and wow, this is a nifty tool. You freaking import it and you send it out. And just to put things into perspective, again, I like to point fingers to Cisco. This is our one of the security products, Firepower. And if you see in there, and of course you're not going to be able to see, but everything that you see kind of bluish in there is one entry for every single open source component that we have to actually publicly do in there. And if you go to, keep going in the pages, and page 62, that's when it ends, right? And that's, of course, one product. I can assure you, and again, this is not only from a security perspective, but legally you have to say, what open source components you actually have. But I can assure you that every single vendor, that probably of the things that you have in your hand, well, definitely the things that you have in your hand, because most of them are actually completely open source, like Android, or the things that are making us communicating here, or my laptop, they will have hundreds of open source components. Now, this is the thing. Again, I mentioned that we are super spoiled, kind of at Cisco. Yeah, we got hardware that we can put in the lab, investigate things, find vulnerabilities. And it was actually also a little bit different before. We actually had organizations like a Talos organization that we also find vulnerabilities in other things. So let me give you a story about NTP, right? So Talos and an internal organization at Cisco, we found a series of vulnerabilities in NTP. And then yet again, now we are in the middle of actually disclosing this to not only vendors, but the maintainers of NTP, which never, prior to that, they confirm, and it's publicly, they never looked into actually looking into security testing for NTP, and ever. And what NTP is used for? So if your time doesn't work, what things will not work? Right? And the things like certificates, right? Things that are core to security. But anyways, I'm not going to bore you to death in there. But basically, of course, yeah, we work with them, and we are amazing. How many of you are from Red Hat? Anybody from Red Hat here? Okay, so if somebody's here from Red Hat, you should take pride of yourselves. I work pretty closely with their PSIRT team, and they're amazing. And in a lot of cases, Red Hat not only is disclosing the vulnerabilities, but they actually are trying to figure out how to fix it, because nobody else is going to fix it in the industry. So we collaborated with them, and we disclose this, to the public, and people hopefully patch. But then you say, wait a minute, hold on. You just told me that your security product has like 62 pages of open source in there, and Cisco found it, and then yet you have an advisory that doesn't have fixes. What the hell, right? So this is the story about that, right? Whenever you have a vulnerability like this, even if you can be somewhat of a competitive advantage that you provide the fixes, even discloses this internally. We have over 70,000 employees. For the people to actually fix everything at Cisco, you can rest assured that it will be leaked. Not by, maliciously, but just 70-something thousand people that probably are going to share this thing. And, they're going to talk to their neighbor that also works with NTP, and, that thing is going to get leaked. And that's most of the times these leaks are used in the corporate world, not the shadow brokers, but all these leaks are, by mistake, right? Not some of the other ones. But this is the things that complicate the problem. Cisco, and again, that's what I like to point fingers. Cisco, we found the vulnerabilities. We didn't tell anybody until we actually worked with some of the vendors that were impacted. So again, let's take Red Hat as an example. It can be anybody, right? But Red Hat, has a distribution that Cisco also used to create their products. So now, from here to here, and this is time, it probably took, I don't know, Red Hat about a week or so to actually get fixes in there. Now we cannot patch our own products because we're waiting for an upstream provider to do that. So that's time. Let's say a month, 3 weeks. I don't know, because there's so many products that are affected by this, so it all depends. Now you patch, even though you found the thing from the beginning. Then it can be a white label that some guy that actually decided at Cisco that we were going to sell this very cheap thing. I'm not going to mention things, but we do. The white label, and now those people, they also have to patch. And this is super simplistic. I mean, this chain, it can go many, many different vendors deep. And the challenge is the customers are all the way back there, right? So again, you probably found this, you accelerate it, you probably have fixes, even, let's say it's the same day. I can assure you that right now, there are many, 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 many customers, and this is probably whenever we started looking at NTP about a year and a half ago, that they probably don't have the fixes. And I'm not talking about the vendors having the fixes, but the customer have implemented, right? And I'll leave that to you. Thank you. All right, so how the hell do we modernize and accelerate all this, right? And especially, I mentioned that I average, Cisco averages 2.5 vulnerabilities per working day. That's advisories, right? Actually, I should have said that. It's 2.5 advisories per working day. One advisory may have multiple vulnerabilities. So, you can do the math. And we also average 150, we acquire a company called IntelliShield. So we create IntelliShield alerts for third-party software publicly. It's in cisco.com. We average 150 of them per week. Right? So that means that this, forget about the logos, no Red Hat, not Cisco, but there's 150 open source vulnerabilities per week that we investigate. I'm not talking about patching, I'm talking about investigating. Now, having said that, before I go into all that, I know that we're kind of going around time. Let's say you have CV 2019, blah, 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 blah. That's one CV, one vulnerability of 150 per week. That if you are a company like Cisco, we basically automate the bug filing for this thing. Whenever there's a heartbleed or shell shock and everything before, that used to happen. It's like, you pick up the phone and you start asking, the BUs, not anymore. We file the bug and everybody's affected. It's like you're innocent until you're proven in court. Is the complete opposite. You're definitely affected unless you actually prove me that you're not affected. So it's pretty disruptive for Cisco. But again, we average about 500 bugs every time that we do these, large disclosures for things like an OpenSSL and everything else, right? Anyways, the thing is, we need everybody here, and I'm not talking about Cisco here, but everybody, we need to actually really maintain competitive advantage. We have to make and contribute to open source. It's huge, right? But we also have to understand that the hidden cost of open source is not, open source is not free whenever it comes to security, right? People have to actually literally pay attention to that. Now, vulnerability management, before it was not easy, but it's not like it is today. Why? Because now not only you have to worry about patching systems like your desktops and your infrastructure devices, but literally things that you're also putting in your infrastructure that didn't exist before, a connected thermostat that nobody's actually scanning. I work very closely with other scanning vendors like the Qualys, the Rapid7s of the world and everything. And one of the things that I'm actually hearing from many of them is like, yeah, they have continuous monitoring and things like that, but a lot of customers, they don't even scan their IoT devices are on the same VLAN that your users are. It's like, wow, okay. So, but anyways, outside of that, what we're actually trying to do is human readable, so an advisory, those 2.5 advisories that I'm averaging per business day are slow and inefficient. How many of you have read a security advisory, for a Cisco product? Okay. How many of you have read a security advisory for any product? Right? We're doing something very wrong. We need machines to read that advisory. We don't need humans. Humans don't understand the technology. He will not probably patch. He will be inefficient just by the time you figure out. So what we're trying to do, especially whenever one of the major barriers of security nowadays is budget constraints, right? And we see this over and over and over. This is part of a security annual report that we posted there. But budget will always be one of the major constraints. And if we keep that humans actually are digesting the security information and the news nowadays, we're not going to win. I can tell you that for a fact, and it's going to get worse. I wish I can say something different, but it's not. So what we're trying to do, and actually this is what kind of my only call to action in here, we're actually trying to modernize the way that vulnerabilities are actually disclosed nowadays in machine-readable formats. And I'm the chair of a new standards TC called a CSAF, Common Security Advisory Framework. And basically the ability is to create machine-readable, and we actually now do in the Common Vulnerability Reporting Framework, CVRF, machine-readable advisories that things can actually ingest, whether it's your SOC and display that information there for a human, yes, that's fine. Whether it's an automated that is a vulnerability in a desktop and your desktop support team actually have to patch and route that, or a scanner, or the device actually to be able, or the product in the management to be able to ingest that, and basically, I will not say automatically remediate, it depends on the scenario, right? For a phone or a desktop, automatic remediation is pretty simple. For an infrastructure, you can actually cost half of Europe to go down if you apply the patch that is not supposed to be there. But again, accelerating this, right? We actually have now this 1.2 version active, and the ICASI, the organization that I mentioned before, they actually were the one that originally created CVRF, and now it's getting a lot of more attention. Again, ICASI is only around 10 companies. Now we have close to 100 organizations actually, trying to accelerate this, right? So what it is that, and I know that I'm running out of time, but what it is in essence is actually that you can have all the machine-readable contents and standards of the world and science fiction, or science projects like this, but if there's no adoption, it's a moot point. So what we're actually trying to do is actually create tools, and I'm talking about free tools, to be able to actually not only generate the content, but also consume that content. If we do not do that, and if we do not adopt it, I can tell you for a fact that right now, with all the confidence that I have in the world, we will not keep up with the vulnerabilities. It's going to continue to increase. So with that said, know that I'm between you and lunch, but any questions? Yes?
Is there any move to standardize maybe this is part of the effort, to standardize generation of software to come with, I know at Cisco we use, but like a manifest that contains, so when I'm downloading an app from the web or downloading an app to my phone, it's got some sort of standardized way that lists all the things it has involved in it, so that like the OS or something can help me match these two things together and say, I know there's a problem with this, you have software that contains this, you can fix it.
So the question was, is there a standard way of enumerating what a product actually has, like a bill of material, or actually the nomenclature of a product? The bill of material, in essence, is actually the product identifier, and there's two. One is called CPE, Common Platform Enumeration, and then the other one is a newer standard that hasn't been adopted as we want. It's called SWIT, Software ID Tags. And basically the idea is that for any product, not only for security reasons, but also for licensing and legal issues, that you will enumerate that using those standards. Right? We do have a long way to go there, but there's two standards now for that. Yeah. Right. So if there are other questions, thank you again for your time. And